All right, looks like we're live. Hi, my name is Jenaca Willans. This is my final presentation for CIT 260, Object-Oriented Programming. This presentation will include a review of the midterm rubric as well. As I go through our team project, you will see lines of code commented out. These are a product of debugging. All right, let's see, share my screen. I will begin by reviewing 7 steps in the development and design process. This is a design document for one of our program calculations. Steps 1 through 3 clearly state the problem and what the player will need to accomplish a task. Step 4 lays the validity rules for the numbers used in the calculation. Next, we have the test matrix. We have columns for valid and invalid input, as well as columns to test the boundaries of valid input. The invalid cases test input that is against the rules, such as negative integers. Now we need to outline and create an algorithm to perform the calculations. We must handle errors from invalid input, then walk through the steps in the calculation. We use the outline to create the algorithm, or pseudocode. Walk through the algorithm step by step to validate the matrix and document the volume or results of each test case. Ensure that the actual results match the expected result. Here's the code developed from the algorithm. This is used in the alter test class. When we run this test, the values here are input into the code from the control class. The expected result is listed, and the actual result is received from control to the variable result. The assert equals function, or method in Java, compares the expected result to the actual result, and the test passes if they match, these here. When they all match, we commit our changes and push them to the repository. While we are here in a control class, I will review a selection statement and how it works. The height and width are parameters here that are passed by value to the method. We use an if statement to compare the variable values. If the height is less than 1 or greater than 4, it is not in range and the program must throw an exception. We have created our own exception handling class used here. If the value is in range, we move on to the next method. Another selection statement is the switch statement. This is best used for a list of choices, and the program must decide which action to take based on the input. In this case, the user selects what they want to do inside the game. The user enters a letter corresponding to their choice, which we have assigned the variable choice to represent. If the user selects a letter that matches one of the unique cases listed, the program executes the instructions. Here it will call the function associated with the input and then break out of the switch statement. If the input does not match a case, the default, in this case an error, is executed. Next, we will review the basic for loop to fill an array. This method fills the array with random numbers calculated above and set to the variable random. We declare a variable integer I and set it to 0. For each loop, I will represent a new value. Again, in this loop, we begin with 0 since arrays are 0-based. We compare the value 0 to 100. It is less than 100, so we continue with the loop. We will assign a random number to the W variable, and then use array add to place the value at the 0 spot of the array. We also have a statement that will give us the sum after 100 iterations. The ++ is an instruction to increment I by 1, so now it has a value of 1, and we again compare it to 100 and place another random value in the 1 spot of the array. This continues until we've incremented by 1s to 100, which is no longer less than 100, and we break out of the for loop. Next, we will review the difference between static and non-static methods. Here we have the main method, the starting place of the program. It is declared as static because it is final or constant. Static functions do not need to have a new instance object created in order to be used. Many static methods are found in classes that are standard in every Java program, such as the input-output class. You can see here that we have imported portions of the input-output class to be used in the Nephi's Journey class. If the method is not static, we must use the constructor to create a new instance of the class and assign that instance to a new class variable. We see this in our call to the start program view. We have a class called start program view, and we must create a new variable to hold this object. We will call it start program view, which is the class variable name. It calls the method start program view, and the game displays the welcome message. Here we also have examples of reading and writing files. These are handled gracefully with exception errors. We want to use character stream classes because we want the program to be compatible with UTF-8 Unicode. This way it can be easily extended to international users. When main is called, the program begins by trying the following. We wrap the byte reader and byte writer in the character class constructor and call these new instances of these Nephi's Journey in file and out file. These are new class variables that call the methods listed to open new files. We then start the program. If there are any errors opening the files or starting the program, those methods found in their respective classes throw the errors back to main, and they are caught here, and the user sees the error printed to the console. This method uses the basic throwable class standard to Java. Whether there are errors or not, control of the method moves to finally, where we try to close the files. Again, errors are caught if thrown by the respective classes. If this was a try with resources method, the variables would be set within the try statements, and the files would automatically close because the scope or lifespan of the variables resides within the try block. Once the block ends, the memory reserved for the variables would be destroyed. I briefly mentioned arrays earlier. There are 3 types of lists that we can create and work with in Java. The first is an array. This is a fixed length collection of items of the same type. If the number of objects is unknown at compile time, or if the list will include different types of objects, we can use an array list. The last type is relatively new to the Java language. It is enums, or enumerations. They behave similarly to arrays with some important distinctions. Like arrays, these enums are objects of a class, in this case, the item class, where items within an array list can be updated as shown earlier. Enum lists are constants. The items in the list cannot be changed, and they must all be the same class or primitive value type. Thank you for your time, and I wish everyone out there a great day.